Okay, here we go. Sorry, Sini, second year. The definite integral. Today we learn about the indefinite integral. The definite integral can be written as follows. You've learned that. And using the fundamental theorem of calculus, part 2, when we saw bounds, meaning definitive, okay, definite boundaries, we said that that was equal to the antiderivative evaluated at B minus the antiderivative evaluated at A. So what is the indefinite integral? The indefinite integral does not have bounds. So when we're asked to find the indefinite integral, what we do is we simply take the antiderivative. Only we have this slight change. We add a constant on the end. I will show you. So look at this example right here, okay, the definite integral. Everybody okay with that? Okay. Indefinite integral, simply the antiderivative. I don't plug anything in because I don't have any boundaries. Why does it have the c on the end? Well, if I had f and I had f prime, for example, if I had x squared, what is f prime? 2x. If I ask you to find big F for the antiderivative, what would you tell me? X to the third over 3. Well, so I'm going to suggest to you that I could have come up with another one that would have the same first derivative and second derivative. What about x to the third over 3 plus 5? Would you agree? Even x to the third over 3 plus e times pi times the sine of the square root of 2 divided by 146,000, yada, 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 right? So we'll get to that when we get back. Okay, we left off with this idea that if you take an antiderivative x squared, you could get x to the third over 3. But you can also get x to the third over 3 plus any constant. Because we take the derivative of a constant, you get 0. So that's why for our indefinite integrals, when we take the antiderivative, we attach the c on the end. Okay? No. You should write c as an expression. It will say, when you find a indefinite integral, you should write c. If the question was find an antiderivative, then you could put anything. Okay? So it says verify by differentiation that the formula is correct. So they are making a claim. The integral of negative x sine of x. Think about that. If I told you to find the derivative, or the antiderivative of negative x sine of x, that's challenging. That's like trying to undo the product rule. And that's difficult. We got to use something called integration by parts in order to solve that. And we don't know that yet. So they're making a claim that it's equal to x cosine of x minus sine of x plus c. They want to verify that this is correct. So what we're going to do, yep, they're saying that the antiderivative of this is that. So what we're going to do is take the derivative of this and hopefully come up with that. Okay? So they're saying that big F of x is equal to x cosine of x minus sine of x plus c. What we want to do is find the derivative. The derivative of big F is little f. And so what do we have to do in order to find the derivative of x cosine of x? We have to use the product rule. The derivative of x is 1 times cosine of x plus, so minus sine of x times x. So minus x sine of x. What's the derivative of sine of x? Cosine, so minus cosine of x. What's the derivative of a constant? 0. Yes, cosines cancel. So we are left with negative x sine of x. And that's what we have right there. So therefore, this is done correctly. Okay? Sure. Check mark, box, QED, done. Well, so they're saying that this is the antiderivative. So to say that it's the antiderivative, I call it big F. And then when you take the derivative, you get the original function, f. Or f and f prime, notation-wise, would be the same. Okay. I'll look at example B. The integral of the square root of ax plus b dx. Apparently, we've got 2/3, or 2 over 3a, times the square root of ax plus b cubed. Interesting. Apparently, that's a formula. If we were to look at the back of a Calculus 2 textbook, you would find pages, probably about 5 pages listed of formulas like these. Okay? Because finding antiderivatives of some things can be difficult, so they put them in forms like this. So we want to verify that they are in fact true. So a and b are just numbers. X is our variable. Don't pretend you didn't say it. Ooh, wow. Those were fighting words right there. Okay. I'm going to rewrite this. I'm going to say f of x is 3 over, whoop, sorry, can't do that. 2 over 3a times ax plus b to the 3 halves. How's that? Is that okay? If I want to find the derivative, what do I have to use? What rule? Just the chain. This is a constant. This is like 4 or something. So you don't have to use the product. If you had an x out front, then you'd have to use the product rule. This will only require the use of the chain rule. And so what I have is 2 over 3a times u to the 3 halves plus c. U is my inside. What's my inside? Ax plus b. Thank you, Megan. What's the derivative of ax plus b? It'll just be a. Look at this derivative. What's the derivative of c? 0. And if you bring the 3 halves down, what's going to happen? 2/3 go away, but I'll have 1 over a that's left. And I'll have u to what power? U to the 1/2. A times 1 over a times u to the 1/2 is going to be equal to just u to the 1/2. Substitute u back in, and we have the square root of ax plus b. And that's what we're supposed to get. What do you think? Any questions on that? Yep, so you should verify by differentiation that this is correct. So you see the c, you take the derivative, you get nothing. Okay? All right. Example 2. Find the general indefinite integral. So, indefinite because there's no bounds. So I'm going to add 1 and I get x to the 4 over 7 divided by 4 over 7. It is a negative, but because I add 7/7, negative 3 goes to 4. So you got 4/7. So I get 7x to the 4/7 over 4 plus c. That's my answer. We're taking the antiderivative, putting a c on the end. Yes, Matt. That's correct. This is big F, yes. Like when we use technical. If you look at B, you would distribute the 2x. Now, if you didn't distribute the 2x, you'd be undoing the product rule, right? Because if you were to take the derivative, you would use the product rule in that scenario, wouldn't you? So if you're going to take the antiderivative, got to figure out a way to undo the product rule. And we, like I said, we haven't learned that yet. That's later on after we review for the AP Calculus exam. It's called integration by parts. It's really cool. It's a nice technique, but you are very limited right now. You know how to take derivatives, and then you know how to take antiderivatives of things with powers and some trig functions. But that's about it. So we got to write it as a power. So we have the integral of 2x minus 6x squared plus 2x to the 6th dx. What's the antiderivative of 2x? X squared. Antiderivative of 6x squared. 2x to the 3rd plus 2x to the over. If you forget to write plus c on the test, I take a half a point off. Well, she was being dramatic. Megan's kind of a drama queen. Oh, wow. Okay. All right. How about for C? Pull it out. So I have the integral of 2. Negative 2g and positive 3g make plus g. Minus 3g squared dg. What's the antiderivative of 2? 2g plus g squared over 2 plus g to the 3rd plus c. So proud of you. She's talented. She can do math problems. All right. Next one. What's the antiderivative of 4 sine? 2 sine. Negative 2 cosine. What's the antiderivative of 4 sine? 4 cosine. 4 sine. There you go. Because if you take the derivative of cosine, you get negative sine. So if I were to take the derivative of this, I would get a positive 2 sine, correct? So we go backwards, pay attention. Oh, this part right here. Okay. Oh, I erased it. Because the derivative of sine is positive cosine. The derivative of sine is positive cosine. The antiderivative of sine is negative cosine. Okay? All right? Okay, you guys, I'm going to get to a question Sini's asking, and then we'll move away from this, but this is pretty important, okay? So, right here is the integral of sine, and you can see it says it's negative cosine. So what's the integral of negative sine? Positive cosine. Here it says the integral of cosine is sine, so the integral of negative cosine would be, it's very common for students to get confused back and forth, you know, as they look at derivatives, things of that nature. I thought I had made modifications to this sheet. Be submitted elsewhere. Anyway, so that's what you got to keep in mind, okay? Keep that straight, okay? Scott, is that a question? Just resting your arm. Okay, great. Does that answer your question then, Sini? Yes, Megan. Okay. All right. Let's try a more difficult one. Letter E. What to do? Emerald has an idea. What was your idea? Okay. Make it secant squared. Won't work. Won't work. You want to use the quotient rule? That's if you're taking the derivative. We're finding the antiderivative. Come on. Okay. Bo's close, but he's not right. Sine squared of x plus cosine squared of x. Well, he was the only. You didn't say anything. Okay. So as you look at this, this is a trigonometric formula that I know that you recognize. And if we simply play around with it, if I subtract the 1 and subtract the cosine squared, I get, you can see that sine squared of x minus 1 is equal to negative cosine squared of x, correct? So we have the integral of cosine of x over negative cosine squared of x. We can make that substitution. You take cosine divided by cosine squared, you get 1 over cosine. And what is 1 over cosine? So I have the integral of negative secant of x dx. Very good. What's the antiderivative of secant? Not secant tan. Antiderivative. Antiderivative secant. Come on. Tangent squared. Nope. Tangent times secant. Good guess. No. You don't know this one yet. This is this is challenging. You know that the what? You know that the antiderivative of secant is, I'm sorry, you know that the derivative of secant is secant tan. But you don't know the antiderivative of secant. The antiderivative of secant ends up being the natural log of the absolute value of secant of x plus c. So, you know, we don't know that yet. So I put this there so you guys could understand that we don't, first of all, you see a substitution, but second of all, we don't know all of these yet. Now, we're not going to give you ones we don't know, but I just want you to understand that there's ones out there that it's going to be a while for us to calculate. So, F, look at your various calculus note sheet. I gave it to you. See if you can find a substitution for F. See if you can find the substitution. There's a, yep. F, find a substitution. What do I do here? Gotta find it. What? Bo sees it. Bo sees that sine of 2x is equal to 2 sine of x cosine of x. This is reviewed from last year, people. Look, right here, okay? Double angle formula. Sine of 2u is equal to 2 sine of u cosine of u. You guys know that? No. Gosh. Keep up. It's tangent. Yes, you should know that. Okay? We have two formulas here. Okay? Sine squared cosine squared is 1, and sine of 2x is 2 sine of x cosine of x. These are ones you should know. And yes, you should know that tangent is sine over cosine. These are things you need to keep at the forefront of your brain. So when I make the substitution, I get the integral. It's going to be now 6 times the sine of x times the cosine of x, all over the cosine of x, dx. What happens? Cosines go away. So we have the integral of 6 sine of x dx. What is that? We'll show it to you later on, okay? We haven't taken the antiderivative. No, I don't want to talk to Sydney. I'm done with her. Okay. All right. Now, what's the difference between letter G and the ones we just did? These are definite integrals, so we will apply the fundamental theorem of calculus part 2. Before I do that, I'm going to do something a little bit different here. What? Constant. Constant. It doesn't stand for chickas. No, it's not named after you. All right. So I'm going to break this up because I can't find the antiderivative right now. I must write it as a power. That's where we're limited. We're limited to do just that. So I have the integral from 1 to 2. What is 1 over the square root of x? I have to write it as a power. X is negative 1/2. That's the only world we know right now, really. Okay? Except for some basic trig stuff. This is x to the 1/3 divided by x to the 1/2. What do you do when you divide? Subtract the exponents. What is 1/3 minus 1/2? Negative 1/6. Very good. So minus x is negative 1/6 dx. So this is the integral we are now trying to evaluate. Subtract when you're dividing. When you're dividing, subtract the exponents. Nope. Nope. This would be review. Just more practice. Yeah, we had problems like this on our last test. Well, not quite this difficult with the exponents. I picked some tough ones because I knew where you guys' struggles are. Exponents. All right. So I take the antiderivative. What's the antiderivative of x to the negative 1/2? X to the 1/2 over 1/2, or multiplied by 2. So 2 roots of x. What is the antiderivative of x to the negative 1/6? X to the 5/6 divided by 5/6, or times 6/5. Hopefully you've gotten used to that. Reevaluate that from 1 to 2, or at 2 and 1. I plug it in. Plug in 2, I get 2 roots of 2 minus, what is 2 to the 5th power? 32, so I have the 6th root of 32 then, right? So 6 roots, 32. I'm sorry, Megan, it was a really good guess. I'm sorry I laughed. I didn't mean to. I thought you were joking there for a second. Sorry. I didn't realize you were honest. Sorry. I'm sorry. I know, I know. I'm sorry. I'm really sorry. It's still not 4, but it's okay. Okay, it's a bad teacher moment. Then I plug in 1. And if I plug in 1, I get 2 minus 6 over 5. What is 2 minus 6 over 5? That's 10 over 5 minus 6 over 5 is... So my final answer would be 2 roots of 2 minus 6 sixth roots of 32 over 5 minus 4/5. So that's the exact answer, okay? No, not plus c, because this is a definite integral, okay? So tomorrow we will finish up these 3 problems, and you will have then the rest of the hour to work on a lengthy assignment. Really? Oh, sure. All right, if you want. Okay, all right.